Evening, girls. I promised you I would go through this question from your midterm because it's quite complicated. There's a lot of stuff going on here, and I wanted to make sure that there was something to talk you through it step by step and not just the solution that I sent yesterday. So here I am. Let's go through it. So we have the equation 3 over x plus 5 equals negative 2x plus c. C is a constant term, and we know the equation has no real roots. This is a clue to how we're going to have to solve this question. It means we're going to have to use the discriminant, which is b squared minus 4ac. And if it has no real roots, the value of the discriminant has to be less than 0. We want to find the range of possible values of c. So we are going to essentially be solving an inequality and finding an interval that tells us an interval that c lies within. So the first thing is that the equation we've got so far, the equation we've got right now, doesn't look like a quadratic. There's no squared term in there. So how do we use a discriminant on something that's not a quadratic? We need to use some algebraic manipulation to make it look like a quadratic, to get it into a quadratic form. So to do that, what I really need to deal with is this fraction. I don't like that. I do not want that fraction to be there. So to do that, to get rid of that, I need to multiply everything through by x. Important thing is everything. So every single term in that equation needs to be multiplied by x. A really common mistake is that people kind of multiply the fraction and end up with 3, but forget to multiply the 5 by x as well and kind of miss terms out. So make sure everything in that equation is multiplied through by x. It's kind of like, when you did simultaneous equations at IGCSE and you'd have like x plus y equals 6 and then x plus 2y equals 7, and you wanted to make the first equation have the same amount of y as the second one, and you'd multiply everything by 2, but you had to multiply everything by 2. So this would become 2x, this would become 2y, this would become 12. Do you remember doing that? This is a similar kind of thing. Everything has to be multiplied through by x in order to keep the integrity of the equation. We don't want to change any values. We don't want to make it into a different equation. So to do that, we have to make sure everything is multiplied through by x. Yeah, it's a bit off topic, but I hope that little aside helps a bit. So we're multiplying everything in that equation by x. So 3 over x multiplied by x leaves us with just 3 because an x on the top and the bottom of the fraction would cancel each other out. 5 multiplied by x is 5x, and that is equal to negative 2x multiplied by x is negative 2x squared, and then c multiplied by x is cx. I want everything on one side so it's equal to 0, and then I can begin starting to use the discriminant. So I'm going to move the 2x squared and the cx over to the other side to avoid having a negative amount of x squared because it's not my favourite. So I get 2x squared, I've got this plus 5x, and I've got minus cx, and I've kind of grouped them together in the middle to help to make the next step a bit clearer. And then I've still got this constant term 3 at the end, and it's now equal to 0. Now I need to know my value of a, which is 2, because that is the coefficient of x squared. My value of c is 3, because that is the constant term at the end. But the problem I have right now is that I have 2 terms that have x on their own in. I need to group the 2 coefficients together in order to find out what b is, because right now I don't know. So to group those 2 things together, normally if c was a number instead of c, if it was a number we knew, obviously c is a number, it's just a number we don't know. If c was a number that we knew and say it was like 2 or something, we would do 5 minus 2x. We'd do 5x minus 2x would give us 3x, and that would be nice and straightforward. We can't do it as easily this time because 5, we can't take c away from 5 and give a singular value until we know what C is. So we have to just simplify it as algebra. So 5 minus C, we're just leaving that together in a bracket, and that is our coefficient of x plus 3 is equal to 0. I hope that makes sense. I feel like I've talked around it and I'm not sure I've made coherent sense. But anyway, now I have my value of B, which is 5 minus C. I'm going to put that into the discriminant. So A is 2, B is 5 minus C, and C is 3. And I'm going to put that into here. Siri's convinced that I'm talking to him. Anyway, B squared is 5 minus C squared minus 4 multiplied by 2 multiplied by 3. And that has to be less than 0 because our equation has no real roots. I'm going to leave the bracket as it is. I'll explain why in a second. And then 4 times 2 times 3. So 4 times 2 is 8 times 3 is 24. So minus 24, less than 0. Now I'm leaving it like that because if I expanded the bracket out, simplified it, I would get a quadratic that I am unable to factorize, and I would have to complete the square to solve it, which would lead me straight back to this expression that I've already got. It's already in completed square form. We've got the variable is squared. We've got the bit that we've taken away from it. It's already in completed square form. So I'm going to just solve it from here. So to do that, I'm going to add 5 minus C squared over to the other side. I'm going to change it to an equals for now and solve it as if it's an equation. I'll explain why in a second. Then I'm going to square root plus or minus the square root of 24. And that is why I've changed it to an equals for now. Because when I'm square rooting and getting two values, if that's still an inequality, my inequality is going to split into 2 because I have 2 values. I can't have 5 minus C is less than plus 24 and negative 24. That doesn't make sense. So I'm just going to solve it as if it's an equation, and then I'll deal with the inequality at the end. I still need to move some stuff around to get C on its own. So all I'm going to do is add the C over and then move the 24 back over to the other side. So I end up with 5 plus or minus root 24 is equal to C. So I've kind of just swapped these around by adding the C over to make it positive. I don't want it to be negative. And then obviously it's plus or minus root 24. So I'm going to subtract it and add it over to the other side, so it still ends up being a plus and a minus here as well. I hope that makes sense. Yeah, I'm not sure how else to explain that. If it was plus root 24, I would subtract it over to the other side. If it was negative root 24, I'd add it over to the other side. But it's already both, so I'm going to have to do both to move it. So it still looks the same as it did, even though we've moved it to the other side of the equation and done the opposite. I guess you could write the sign the other way around. That's the same way around. Like that. Because I've minused and added. I think I'm overcomplicating it. I've swapped it around. I've moved it. I've swapped the C and the root part. But now I have my two values of C are 5 plus root 24 and 5 minus root 24. But it is an inequality. And it's a quadratic inequality because we were solving a quadratic expression, 5 minus C squared minus 24. So I need a sketch. I need to think of when we were doing quadratic inequalities. I need a sketch. If I were to multiply the 5 minus C squared bracket out, C would end up as a positive square. The square part of the expression is positive because negative C times negative C would give positive C squared. So it is going to be a positive quadratic. It's going to look like that. And it is going to have roots at 5 minus root 24 and 5 plus root 24. Those are my two roots of the quadratic where it's crossing the x-axis. Now, we want it to be less than 0. So if I go back to here, we're looking at where it's less than 0. So that means we're looking underneath the x-axis. We're looking at all the negative y values. These are all here. So that means C is in the middle of 5 minus root 24 and 5 plus root 24. Oh. So C is in the intervals 5 minus root 24 and 5 plus root 24. That's the bit that gets a bit confusing. So once you start to solve at this point, once we start to solve here and we realize we've got a quadratic inequality that we're having to solve, it is best to change it to an equals, find your two roots of the equation, sketch the graph, and then decide which part of the graph you're interested in. So because we're looking at less than 0, we're looking underneath the x-axis instead of above the x-axis if it was greater than. So we are interested in the values of C that are in between these two values, okay? If the inequality was the other way around and we were told it had 2 real roots instead of no real roots, so we were using the discriminant the other way around, so like that, when we get to the end and we've sketched the graph, we would be interested in these parts of the graph. And so the inequality would look slightly different. These ones we'd be looking at values that are less than, so C has to be less than 5 minus root 24 and greater than 5 plus root 24 instead of between the two values. Oh, I haven't got enough room to write 24 in there, but you know what I mean. Yeah. So I hope that helped. Maybe have a little look back over your notes on quadratic inequalities. But this is what I mean when I say, whilst a P1 paper usually has about 10 questions on it, most of the time one question will be testing you on more than one thing at once. So we've got quadratics here using the discriminant, and we've also got quadratic inequalities. That's 2 different chapters of the textbook. That's your chapter on quadratics, which was chapter 2, I want to say. Could be wrong. But that was chapter 2 in quadratics. Chapter 3 was equations and inequalities. So solving a quadratic inequality was in chapter 3. So we've done those in isolation. We've done them separately in class, but in an exam question, it's very likely that they'll put all of that together and you have to do them all in one question. It was with 7 marks, I want to say. It was with 7 marks. So it's a lot of, it is a lot of work, but you get a lot of marks for it. And even if you say only get halfway through, the chances are you'd still get 3, maybe 4 marks. Even if you don't get all 7, even if you get to the end and are not quite sure how to finish the inequality, you should still get a few marks on this, even by just doing, putting it into the quadratic form, using the discriminant would be a mark, and substituting the values into the discriminant. Like, there's lots of opportunities to pick up marks because there are 7 of them up for grabs. So whilst it is difficult, there's a lot going on, there's also a lot of opportunities to pick up marks as you go through that question as well. So try not to be too daunted by these long questions. I know the first half term into year 12, it can be a bit mind-blowing. I can't think of a better adjective. But you will get used to it. By the time we come to do this exam in the summer, you lived in so many practice papers and so many exam questions that you will just recognize what's going on without really having to think too much about it. and that, honestly, speak to year 13, it does happen, it will happen. But right now you're taking in a lot of information, and it's difficult to pick out what exactly you need to use, but it will happen, so don't stress about it. I feel like I've just given you a bit of a pep talk at the end of that. Hope it helped. Let me know in class if you've got any more questions about this, because like I say, it is difficult. And again, if there are any other questions about the other solutions for the midterm as well, let me know and we can go through them in class together. But I just wanted to make sure this one, you had a clear, at least I hope it's clear, step-by-step kind of guiding you through what I did to solve this question. Okay, thanks for listening if you've listened all the way to the end, and I'll see you girls in class. Thank you.